Today we'll be discussing about machine code and its interaction with the CPU, and how the CPU operates accordingly. Let's start off with explaining what machine code is. So computers deal solely in numbers. Programs that are stored on a computer are stored as sequences of binary numbers, which represent instructions. This raw state of the instructions is known as machine code. This is true for all programming languages, as well as including JavaScript, Visual Basic, and etc. High-level language statements, such as the one shown on screen, are compiled into machine code before being executed. And just below the high-level language statement example, there's a snippet of machine code, which, as you can see, are just a bunch of binary numbers. Machine code works along the operations of a CPU, and what runs the operations are the CPU registers. A CPU register is a small set of data which obviously takes place in a CPU. One may hold an instruction, a storage address, or any kind of data, such as a bit sequence or individual characters. And registers usually consist of a small amount of fast storage, although some registers have specific hardware functions and may be read-only or write-only. So there are different kinds of CPU registers, which all play vital roles for the operation of a CPU, and they are otherwise known as special purpose registers. The first one is instruction register. The instruction register holds the instruction currently being executed. The second one is the memory data register. The memory data register, also known as the memory buffer register or data buffer, holds the piece of data that has been fetched from memory. The third one is memory address register, short for MAR. The memory address register holds the address of the next piece of memory to be fetched. The next one is program counter. The program counter holds the location of the next instruction to be fetched from memory. It is automatically incremented between supplying the address of the next instruction and the instruction being executed. The next one is the accumulator. The accumulator is an internal CPU register used as the default location to store any calculations performed by the arithmetic and logic unit. And lastly, general purpose registers. So I'll just give you an example on how it works. When a program is interrupted, its state, i.e. the value of registers such as the program counter, instruction register, or memory address register, may be saved into general purpose registers, ready for recall when the program is ready to start again. In general, the more registers the CPU has available, the faster it works. An instruction format is normally made up of a combination of an operation code and some way of specifying an operand, most commonly by its location or address in memory, though non-memory reference instructions can exist. Some operation codes deal with more than one operand. The locations of these operands may be specified using any of the many addressing schemes as seen on screen.
The fetch-execute cycle is the method used by the CPU to execute instructions in memory. The process begins with the CPU checking the program counter. The program counter then tells the CPU the memory address of the next instruction. The CPU then fetches the instruction itself from that memory address. Next, the instruction is decoded and executed. Both the program counter and instruction register can be located in the control unit of a computer. The program counter counts the memory address of the current or next instruction depending on the CPU. The instruction register contains information on the instruction being decoded or executed.
A linker. A linker is a computer executable program. There's two types of linkers, static linker and dynamic linker. In computing, linker or linker editor is a computer program that takes one or more object files generated by a compiler or combines them into a single executable file, library file, or another object file. Static linker takes input a collection of relocatable objects, file and command line arguments, and generate as output a fully linked executable object file that can be loaded and run. Use of DLL. Uses fewer resources, promote model architecture, ease development and installation. This provides a powerful and high performance way to extend the function of programs. MS Windows extensively uses DLL.